Alright, I've been meaning to do this video for a while. This is my DIY CNC router, built it myself, have a feature film pretty much on YouTube of me building it. There it is, right there. Link in the description. This is going to be the short version, the more updated version. Parts have changed. Talk a little bit about Fusion, talk a little bit about Mach 3. Lots of good gimbal footage with voiceovers, how I think I'm going to do it, but don't know how it's going to come together exactly, but you guys are going to find out sooner than me, so let's crack on with it if you know what I mean. So here we are looking at it from the front. Switch to the gimbal and the voiceover here, so we'll see how this goes. So swung around the back here. I'm just using my old Alienware laptop, still an i7, and you know, not a bad laptop by any means, but here just load up Mach 3. This is kind of like how you turn it on process, turn on the electronics, multiple power sources. We're going to talk about that one later. Obviously this is the Mach 3 interface, lots of documentation online. Hit reset twice, then we hit reference all home, which will then send each axis in time to go up to its home proximity switch. Every time you do this, well, you have to do this every time you start up. There's a Z-axis going up and then backs off the switch a little bit, and then I believe it will start on the Y, which is the twin ball screws on either side. Yeah. I mean, a lot of this video is just going to be looking, and I'll talk a little bit over some things, but it's definitely a showing instead of like telling type of video I hope to be. And boop, there we go. One of those limit switches. They're not actually limits, but I use them as limits, as they're called in Mach 3. Really, they're proximity switches. But one's over travel or, limit, and then the other is a home. So here we go. We'll just load up the program that we made, the TAP program, which is just a G-code program that Mach 3 takes. We just built it in Fusion. So we're going to go ahead and look at Fusion here and also set up some work holding and go for it. Alright, so here we're going to go over the Fusion 360 side real quick, just as an example. Definitely not a tutorial, as I've mentioned before here. Yeah, so the example today of what we're milling while I'm running you through this is basically a made in Canada symbol with my logo and a little maple leaf on it. That's going to go on the back of these prototypes I've probably shown you here. So I started off in Fusion, just simple drawing the sketch of the size of the engraving I want to do on the back. Then I started with my logo, maple leaf, made in Canada text, and then I also added in an outline that is just to get a work coordinate system off this corner of the backside, so it's going to be really easy to center up. And then drew in the body there as well. We switch over into manufacture. All it is ooh, what warning do we got here? No model selected. Oh, that's easy. Bypass that warning with a little click. Not a big deal. Anyways, yeah, we have one tool path. It's engraved in here. If we go edit, this is just the tool I've set up. We can get into that in a different video. Definitely not a tutorial here. The 4 chains of geometry setup. Most of this stuff is pretty stock in Fusion and how I have it set up. Couple little settings changes, and yeah, we're just going to post-process this here, and we'll be on our way to the machine. And bam, somehow during that time where we also were fusioning, I set up our work holding and such. So here we are. We're going to set our work offset, our 0 position for our program, which is set at the corner of this part as I just shown in Fusion. This work holding is done with my wasteboard, which has 3/8 ground dowels in it, and then the other part of the pattern is 1/4-20 inserts, which are the bolted down hold down, so just holding down and the 3 points there. So I'm just going to set up the corner here off of our 90-degree tool, because we did all this part in Fusion so that the engraving we're doing will be nicely centered in our piece already. Bam, that took us a second, but anyway, she's nice and precise on there. Turn the pendant off, hang it back up. Let's walk around to the Fusion side of things. Oh, Fusion, oh, this is Mach 3, we're already done with Fusion. Just gonna simply jog the Z up because I left it down, because you have to go back to the laptop in this setup to set 0 on the 3 axes, so we're just jogging that up. Way quicker to jog it from over here just because of the way I have it set up. Put it in the spot we want. And I guess because I'm doing this after the fact, I didn't have my work holding tightened down, but of course the piece was set up against those ground dowels or pins. Tighten that up. Check it. Call it good. Tighten her up a bit more, I guess. Got to make sure that wrist bone clicks to know you're up to torque, right? That's how this works. Oh, let's finally press go. Go over and press cycle start. As you can see, it runs the first lines of G-code, starts to spindle up. This here is set at 22,000 RPM, which I think is actually the way my machine setup is a little bit less, but it's not a perfect one-to-one from Mach 3 to what the spindle actually turns at, just because, you know, 0 to 10 plus no way to really tune it perfectly. Alright, so we're just going to fast forward through this engraving here. Bing, 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 blow some dust away, and look at that, we're done. Grab the pendant, set her up on the Z, we're going to move up, go back to the Y axis, we're going to move back, just out of our way. Come on, focus, you fuck. There you go. Alright, so here we go with the walk around, which of course is nicely set up by showing you what we accomplish here with this rig. But so here we have Mach 3, which I already showed you before, in very similar to the state we left it after running that program. It's just in a Windows environment, nothing too special. It communicates with our quotation marks motion controller via USB cable. Some of the higher end stuff, smooth steppers and stuff, have USB options, stuff like that. That little dongle on the side there is a remote control for this cheap pendant, which $140 Canadian. Cheap, has some issues, not going to go into detail. That's the USB port, plugs right into the middle there, which is our motion controller. Oh, I'm just going to grab myself a light here, because, you know, shop lighting, never the world's best. So we're just going to shine it in here instead of opening it up because I'm a lazy piece of crap. Anyways, a little look-a-loo around. E-stop, power, 2 indicator lights, because of course we have 2 circuits here, one for the spindle, one for the control, indicate that they're both present. From the right we have 2 extension cord, aka cab tire SOW, coming in. They go to this 2-pole 40 amp contactor, 40 amp oversize, which is what the switch actually actuates, which are then hooked up to the 2 duplex receptacles, which are, one side is connected to the 24 and 36 volt power supply. 36 volt power supply does all the stepper drives that I just shown there. The 24 volt does the Nuvensun controller and I believe the fan. And yeah, so originally I had the VFD mounted in here. It's too noisy because of how cheap it is, so it got its enclosure to the right. This is a 5-gallon bucket of coolant with a pump. No radiators or cooling necessary for such a small spindle. This is the VFD enclosure. It just sits there. It's hard to call it a VFD. It's more like a frequency converter. It's very, very square wave when you actually meter it. Coming around the side of the machine here, that is just a junction box, lots of wiring hiding in there because this is a half prototype, but much better than my first one. I'm calling this my Mark II. Looking at the timing belt at a 2-to-1 ratio on the 2 ball screws to the Y axis. This machine uses 20 millimeter linear rails. Okay, that's where the coolant starts, comes through the tracks here, up with the spindle, which is in a shielded cab tire variant because it's so noisy. So it just happened to have kicking around in the junk pile and down into the spindle. Added this 3/8 by 6-inch plate on the back of the channel for the gantry because that aluminum actually has a lot of flex in it, and it was a poor material choice when first building this, so that helped a lot, but it was a pain in the ass to install. The whole CNC uses NEMA 23 steppers. The x-axis is a bit bigger because it's run at a 2-to-1 ratio, just because I wanted it to turn faster, but the larger stepper at a 2-to-1 on the ball, the larger stepper inherently doesn't turn fast without losing sync. So we just went 1-to-1 instead of 2-to-1 and tuned it correctly. Looking at the z-axis here for a second, 2 1/2-inch by 6-inch aluminum plates that are ball screwed up with a 500 millimeter ball screw and slides, or 400, one of the two. That works. Wasteboard, it's 30 by 30. Real work area, this is about 32 by 32. It's built in with work holding, and also I'm not afraid to screw into it because it's simple. I do have a dust boot there that clamps on the bottom of the spindle if I'm doing some serious hogging. Oh, great camera work right there. But I guess I'm going to show you all of the different bits I have used in this, or tried, or actually own. Some of the cheap yellow ones from China, some really small engraving stuff. 8th ball mill, single flute, common for doing fine material removal. It runs the ER20 collet system, got a full set of collets for that. Canadian purchased 10mm hogging bits. Other cheap Chinese bits I've tried that aren't that great. This is very similar to the one that I use for this engraving. However, this one I believe is a 60 degree or something different than 90, I believe. Just got an assortment in there. The other cases down below just have an assortment of parts. Oh, gimbal up, nice and rapid there on the GoPro gimbal. Yeah, there is the x-axis stepper. It's larger, 1-to-1. They're all timing belt. That's pretty tight, but it's the way she goes. Got a couple of heat sinks on there to keep it cool. 2-to-1 ball screws, or 2-to-1 timing belt, and pulleys on the every other axis. The whole thing is built on a 1.5 or 2-inch by 1/4 inch angle, more or less, because oh, I know how this is. I skipped over a bunch of stuff just looking at some of the different things I've made. I've also done some bowls which have required a two operation positioning, which is always interesting, but lots of different signs, some with a lot of subtractive there. Of course, there's never any additive, but a lot. Some 3D relief, burnt some like that afterwards, you know, sand it off the top, make it look different, trying different things. Some stuff just fooling around with the boys, obviously, and then like working on simple engraving and stuff and products. And I mean, thanks for watching. This is just a big old overview. I know it's so difficult to cover every base and to really pin down what people want to see, but I'm here. Ask me any questions in the comments. I mean, I built the thing completely myself, so on that note, it should be simple for you guys to get an answer out of me. And if I don't know, I don't really know. Other than that, thanks for watching. Have a good one.